My name is Mathias Dean, and for the related rates problem I will be doing number 45. Here you see the question, our diagram of the person in the screen. Now I've gone ahead and set up my own diagram over here, and I went ahead and because we are trying to solve for the rate of change for theta 1, I went ahead and called that angle theta, or for theta, where I called the original theta angle theta 1, smaller angle theta 2, and the overall angle of the screen to the floor, top of the screen to the floor, is theta 3. And the relationship between the three angles in order to solve for our theta 1 is theta 1 equals theta 3 minus theta 2. Now we know that we're trying to find the rate of change for an angle, so right off the bat we know we're going to be using an inverse trig function. And we also know that we're already given our tangent values, opposite over adjacent, for both of our theta 2 and theta 3 angles. So the easiest way, so you don't have to do any extra math, is to use tan inverse. So theta 1 equals tan inverse, and for the tangent of theta 3, you're going to have 10 over the 30 feet. So that's going to come out over here to 10 over 30 minus tan inverse of theta 2 now, so the 3 over 30. Alright, now because we have everything in there that we need, we can start solving. So theta 1 equals, now for the derivative of tan inverse, that's going to be 1 over 1 plus x squared. And for this exact problem, we are going to have our x be the 10 over 30. So you're going to have 1 over 1 plus 10 over 30 squared minus, before we go ahead and do the subtraction, we have to go in and take the derivative of the inner function 10 over 30, which comes out to be, we're going to have 30 times 0 minus 10 times, now when you're doing the derivatives here, it is tempting to go ahead and put the g prime, which is 30, as 0, but you have to remember that we're giving the derivative of that 30 feet as 3 meters per second. So instead of it going to 0, we're putting it as a 3. If I could make a 3. Okay, and then you're going to go ahead and go all over 30 squared, g squared, minus, and again repeat the same process, and instead of 10 over 30 here, we're now going to have 1 over 1 plus 3 over 30 squared times the derivative of this inner function, which is going to be 30 times 0 minus 3 times, and again the derivative of that 30, the rate of change, is 3 feet per second, so a 3 in there, all over, again, 30 squared. Now we can go ahead and start simplifying. For a lot of people, I know simplification, the basic algebra, can be the hardest part, so instead of skipping it like my math labs and everything, I'm going to go ahead and walk you through it. So we're going to have, I'm going to first go ahead and just bring down this 1 over 1 plus 10 divided by 30 squared, which is going to then go ahead and come out to be, one moment, is the same as 1 over 1 plus 100 over 900. In order to add these up, you have to go ahead and multiply this side by 900 to keep it 1. It's going to be 900 over 900, so you're going to have 1 over 900 over 900 plus 100 over 900. Now you can get rid of this addition by making a sum, which will come out to be 1 over 1000 times, or 1 over 1000 over 900. Now, to get rid of this double fraction, we're going to go ahead and multiply everything by 900 over 1000. The 2 down here cancel, but again, because we're multiplying both sides, you're going to end up with a 900 over 100 on top, which will look like this. Or sorry, 900 over 1000, not 100. So it's going to be 1000, which is also the same as 9 over 10. And again, for the 1 over 1 plus 3 over 30 squared, it's the same exact thing. You're going to go ahead and multiply it out so that you end up getting a 1 over 900 over 900 plus 9 over 900. Because again, you get that 9 from the 3 squared and the 900 from the 30 squared. Go ahead, and this is the same as 1 over 909 over 1, or excuse me, not 1000, over 900. When you go ahead and flip those, you're going to go ahead and get 900 over 909. And of course, you can't just flip it, you have to do math, but you get the gist. And when you divide out 100 into each of these, you're going to end up with what was it? Oh yeah, excuse me, divide by 9, you get 100 over 101. So now, plugging the value 9 over 10 and 100 over 101 is going to come out to be the 9 over 10, so this is still again solving for theta 1, plugging it back into this equation right up here. So we figured out the 1 over 1 plus 10 over 30 squared was equal or comparable to 9 over 10 times the derivative, or the inner function of the tan inverse's derivative, no, the derivative of the inner function of tan inverse, which when that goes to 0 when you multiply, so you're going to have negative 30 over 900 minus, and we figured out the 1 over 1 plus 3 over 30 squared was the same as 100 over 101 times now the inner function simplified, which is going to be negative 9 over 900. Okay, there's an overall view of it. Now, when we go ahead and multiply over, this is the simple part, all it is simple multiplication and division. You're going to go ahead and come out with theta 1 is about 0, or excuse me, negative 0.02099, which you can go ahead and, so that's actually equal. So theta 1 is roughly or about negative 0.0201. And that is the rate of change for this angle right here as a person is walking at 3 meters per second away at 30 feet. Thank you for your time, and good luck with solving all the other equations.